Hi, my name is Ofer Weil. I am a Director of Product Marketing at DriveNets. So, who is DriveNets? Thank you, team, for taking care for this event, and we are really happy to be here. So, who is DriveNets? So, DriveNets is an Israeli startup. It was founded 4 years ago by Ido Suzan and Hillel Kubrinsky, two experienced founders that already sold their startups to big companies, Ido to Cisco and Hillel to AT&T. And they founded this company, DriveNets, in order to change the way networks are built and operated. So the first product goes live in 2017 in a tier 1 service providers in North America. A year ago, at the beginning of 2019, we made our first round from VCs in order to have the fund to go bigger and to support other customers and other products. And today we are more than 2,000 employees in the company, most of them in the R&D. So when we started with the vision to change the way how networks are built and operated, we thought about 4 things. First, software-based, because everything today is based on software. Second is about to scale. Our customers are service providers. They run the biggest networks in the world, and this solution should support these networks. So it must scale. The third one, the architecture must be open, because everything should be open. We need to give the customer the ability to choose, to select. And the fourth is think about simple operation. We all know what does it mean to run these networks, these big networks and complex networks. So from the first day, from day one, we think about simple operation. So it's software-based, scale, open architecture, and simple operation. And when we start with this product, there was a product called Network Cloud. We used to say the DriveNets, we build networks like hyperscaler clouds. And Network Cloud is actually a combination of many technologies that exist in the network. We took virtualization. We took white boxes that are already in the market. We took network virtualization and virtualization in general, and cluster and containers. So we took all these technologies and built Network Cloud. Now, before I go to what is Network Cloud and how we did it, I want to start with the why. Why we want to change how networks are built and operated. And this is a network, and this is the answer. Yes. And the answer is because the networks are so complex. I'm in this market, in the networking space for more than 20 years, you can see on me. And since I started, the networks are operated in the same way. You have different networks. You have a separate network to aggregate your mobile devices. You have a separate network for broadband, separate network for businesses. And it's so hard to converge all these networks. And it's so hard because each network is built with a different type of gears, different routers. So you have a router for core, and you have a different router for edge and for access and for mobile aggregation. So each function is with different router. So as an operator, now you need to operate all these different types. And you need to take care for the support and for the software. So it's so complex. So if you ask why we want to change the way networks are built and operated, this is the answer. Now you might ask, it's clear why you want to change, but how do you know that your customers, the service providers, want to change the way they operate? How do you know? So first, nobody asks. And it's not just you. Every time I present this slide to customers, to service providers, to analysts, they say, we know that. You can continue. Don't spend time on this because everyone knows these challenges, that the network is complex. But this is first. And the second one, we know that our customers want the change because we ask them. Last year, during September and October, we ran a survey. We work with heavy reading, with Sterling Perrin, their analyst. And we came with these questions. And we ask service provider, they ask, and we bring the questions and they ask. And the answers and the results we were surprised. The first question was, do you expect a radical change in your network in the next 3 years? And we talk about service providers, very conservative customers. And as you can see, 46% expect radical change in the next 3 years. And it's a radical change. Only 22% don't expect a change. This was a surprise for us to see these numbers. Now, we didn't stop here. And by the way, I just took three questions from this survey to present here. If you want to see the full report, you can find it on our website to see all the results and all the results of the survey. So we didn't stop about these questions. We also check, what are the drivers for this change? What are the drivers that you expect a radical change? And the answers, lower network costs, because it's very expensive to run these networks, and scale. That's why we said we want a scale network, and reduce operational complexity. So these are the drivers for this change. But we didn't stop here. We also ask, what are the metrics? What are the criteria for the selection of the new solution for this change? And here are the results. Software-based, disaggregated. Lower TCO. So when we ask why we want to change the way networks are built, how networks are built and operated, we see that the customers also see this. These are the reasons. So I started by saying that we build networks like Hyperscaler Cloud. So why Hyperscaler Cloud? And the answer is because hyperscalers solve the scaling challenge. If you think about an IT manager 10 years ago in their data center, they had a dedicated server for each application. And if they wanted a new application, they had to bring a new server. And the scale and the spec of this server was based on the requirements of each specific application, right? If there was an application that needed a lot of resources, they brought a strong server or a small server based on the application. And you couldn't share resources between the applications. So it was very complex to operate. So what they did, they introduced virtualization. They disaggregated between the hardware and the software. So once you disaggregated between the hardware and the software and you add a virtualization layer, now you can run all these applications over the same infrastructure. The hardware resources, the hardware functions become resources, compute resource, networking resource, memory resource. And each application can consume these resources only when it needs it. So you get much better utilization, higher utilization of these resources. And once you do this disaggregation and virtualization between the hardware and the software, now you don't have to buy these strong servers to run this application, right? It's better to go and take small servers, even white boxes. So they can buy the hardware directly from the ODMs. So they built their network, or they solved this scale challenge by introduction of virtualization, disaggregation, and going to white boxes in order to reduce costs. And this is exactly how we built our solution, Network Cloud. Now, service provider networks are not the same like data centers. They are more complex. They have much more customers and locations. So we had to take this model and to adapt it to the requirements of the service providers. But we still built a solution which is software-based and with all these principles. Now, if you look on the left side, you can see that it's very similar to how the networks are operated today. Dedicated hardware, when you have different router or different machine for each function, and we slow utilization of the resources. So when we want to solve the issues or the challenges of the service providers, we can use the same principles. So this is for the why we want to change how networks are built and operated. So let's continue with what we did. So we disaggregated the solution from different levels. We started with disaggregation between the hardware and the software. We are a software company. We just developed the software. The hardware, the customer can buy directly from the ODMs, and they have a choice. Then we said we want to scale. So in order to scale, we disaggregated the control plane from the data plane. So now once you disaggregated the control plane and the data plane, and the control plane is running on separate servers, now you can scale each of them separately based on your requirements. And we took the monolithic router, and we disaggregated it to a virtual cluster. I will show it. And on the software level, we built and we used cloud-native software to run this infrastructure, to run this cluster. So we use virtualization and microservices in order to scale, in order to build a distributed operational system. So this is on the software level. Now, even though we did all these disaggregations, and this is very important, and it's something different from DriveNets and other NOS companies, we don't just provide the NOS. We provide a solution. So even though we did all these disaggregations, we have a central management for this solution. So all these clusters with all these complexity acts as a single router entity, is managed with a single interface. So you get the flexibility of the disaggregation and the simplicity of a single entity. And this is a challenge that we did. So we started with a disaggregation of the hardware and the software. So we provide the software. The customer can buy the hardware directly from the ODMs. There are a few ODMs that already manufacture these hardware that we use. And it's completely open. And it's open means that the customer, if he is not satisfied from our software, he can replace it because he owns the hardware. So he can replace the software and brings a different software. And we know that there are other companies that work to support the same hardware building blocks as we. So we said we want open architecture, so it's open. We took the monolithic chassis solution, with this chassis, and we disaggregated it. We disaggregated the control plane and the data plane. So the control plane is running on x86 servers. And if you need more resources, you can pull more resources to these servers. You can start with 8 cores. You can go take with 16 cores, 20 cores. You can add resources if you want to add more functionality. And the data plane was disaggregated and implemented with different technologies. Now, when the DriveNet started, the data plane was implemented with x86. Okay, it was implemented on the x86 with DPDK, and it was a pure VNF function. And it worked. And it even was deployed in the networks, but it didn't scale. When you want to scale, we found that VNF can't take it. So now we have a different implementation of the data plane using white boxes. So these white boxes is built from two building blocks. One is called NCP, Network Cloud Processing Forwarder, which is like a line card. And we have the NCF, Network Cloud Fabric. Both of them are based on a Broadcom chipset, Jericho 2 on the NCP, and Ramon on the NCF. Now we have these two building blocks. And using these two building blocks, you can build the cluster at any scale. You can start with a single NCP, have a standalone solution. So each of them has a CPU. So you can run NCP as a standalone, have this router. Now, it's a standalone, but it's 4 terabits router, okay? We have two flavors of the NCP, one with 40 ports of 100 gig or 10 ports of 400 gig. And you can use each of them or both of them in the same cluster. And then if you want to scale, you add more NCPs and more NCFs and create a cluster. The boxes are connected with optics cables of 400 gig. Okay? So it's full disaggregated, and you can build this cluster at any scale. So this is the disaggregation of the router. Now, we said we want open. And if you remember, I had this OCP logo at the beginning. So at September, AT&T proposed or submitted a design called DDC, Distributed Disaggregated Chassis, which is a hardware cluster based on merchant silicon and white boxes to create a distributed chassis. And they submit this proposal with three principles. It should run with white boxes and merchant silicon. It should be disaggregated between hardware and the software, and it should scale. It should be able to take any location in the network. Now, as I said before, we are just provide the software. The hardware boxes we don't manufacture, but the boxes that I presented before, the NCP and the NCF, are the same boxes that were spec'd on the OCP. So DriveNets are the first company or the first software that support this DDC architecture. And at the beginning of March, at the OCP Global Summit, we are about to demo a working router with this DDC architecture using these NCP and NCF boxes running at 96 terabit per second. So this will be this will be the size of the cluster. So we said we want software-based, we want to have a scalable, and we want to be open, so it's open. The hardware is open. Every vendor can take the spec and build it and be compliant to this standard.
Then basically MPLS box, you're running MPLS?
So we run also MPLS. So this is the data plan of the router. So you have all these white boxes, the NCP and the NCF. You create a cluster, and you have the control on the x86. But all the manipulation of the MPLS, the routing, is done on the data plane on these boxes.
If you are running a routing protocol on the box, then you're not separating the control from the forwarding plane, correct?
So you run the BGP, the OSPF, all these protocols on your control plane, on your x86. And this control plane, once you complete all these, create the tables, you populate and configure these tables to these boxes. Okay?
So you're centralizing the MPLS, but not
the control, not the routing. The control, we centralize the control. It's like SDN concept, yes. But the actual routing is done on these white boxes. So you get the flexibility of the centralized control, and you get the scale of the data plane of the white boxes.
So you're running something like PCEP, BGP, LS?
Yes.
We expose everything. From your perspective, from the customer perspective, this behaves like a chassis, which exposes everything, in which our control plays the role of a route processor, redundant, and the white boxes act like a line card and like a fabric card. But from operational perspective, you see from the outside world, one CLI, one netconf transaction, you see PCEP, you see BGP-LS. It's like controlling a regular router.
So you're running open protocols.
Correct.
Yes. So the following session would be just about these distributed OS and how we present this complexity as a single entity using all these protocols. Okay? So it's an open architecture. So we started with the disaggregation of the software and the hardware. We thought about disaggregation of the chassis, about the software. So the software is it's cloud-based. We use containers and microservices. We create a virtualization between the virtualization. So all the hardware components become resources. So you can orchestrate these resources to the functions you need. And we have we'll have examples in the next session. We had to rewrite most of these control protocols of the routing in order to scale, in order to support this distributed architecture, and in order to support the scale. And we still talk about central management. All the Northbound API represent to the world a single entity to simplify the operation. So this is a network cloud. It looks like a data center, but this is a router. This is what we are going to build in OCP. This is we already have in our labs in Israel and also in service providers that test and certify this solution. It's a disaggregated. It can scale from 4 terabit to 768 terabits using 192 NCPs. So this is the scale we are talking about. So and this scale can take any network that exists today, in the service provider. And it's based on these white boxes, the NCPs and the NCF that I described before. So this is the network cloud. Now, if we take it to the network, and we started with this complex network, and now we can see how it simplified the operation. Now you have the same 2 building blocks, remember, that can scale, and you can take these 2 building blocks and take them to any location in your network. You start with a standalone box at the access, and then you can increase and build a bigger cluster when you need more ports. So the same building blocks can be used across the entire network. And when you think about the software, we have the same software package running on all these boxes with just different service. So we will have an aggregation service, you will have edge service. So all the boxes has all the resources to support core, edge, aggregation, all these functions. So we have a TCAM and counters in order to support all the features that can be a superset of all these functions. So you can use the same building blocks, and just with the different software features, you can use the same software package across the network. And this is how we simplify the operation. Now, if you remember, in the Hyperscalers cloud, when they use these containers and this virtualization, they can share resources between applications. Now, and we talked about the complexity, or how complex it is to converge networks when you have different routing gears or engines in these networks. Now that we use the same building blocks for all these functions, now we can converge these services to the same infrastructure. So in the same way it works on the clouds, that if you remember at the beginning in the cloud, in the clouds, you have a separate server for each application. And today, it's very clear for everyone that you have a single infrastructure and you have the separation at software, right? You don't care what are the other softwares or what the other applications run next to you in the AWS. You have this separation in the software. In the same way it works here. Once you have this big cluster and you have the software, which is cloud native in different containers, you can run different services on the same cluster and do the separation between the services in the software on different containers, so you can separate the functions. So you can get a better utilization of these resources. Now, once we have this infrastructure, with all these visualization, and once we did all these convergence of all these hardware resources that can use by the microservices, now we can run not just these routing services, you can bring in more services and allow the service providers to run new services on the same infrastructure. They can use the compute resources, they can use the networking resources to run more services. So we actually create the ability for the service providers to generate new revenue, to introduce new services on the same infrastructure on the network. So in the same way it works in the cloud, in the Hyperscalers cloud, when they start with their cloud and then they bring in new services, you can use the same infrastructure here with the same capabilities. Now, we talked about software base, we talked about scale, we talked about open architecture, we didn't talk about operation. And as I said, from day one, we thought about how can we disaggregate the operational model. How can we, even though we disaggregate everything, it's still simple to operate. So we have DINOR, it's DriveNets Orchestrator, which is an application that take care for all the life cycle of this disaggregated model. all the taking from a white box that taking a white box that coming from the ODM, from the manufacturer with no software, and take this white box and bring it to the network with ZTP, with zero-touch provisioning. So you just take a white box. You have a process or something automatic process that install the software. And once you plug this white box to this cluster, everything is done automatically. You just plug in the cables, and all the softwares are installed, all the configurations are downloaded to the box, and you just expand your capacity of the cluster. So we fully automated all these processes, and we have a session about it just to show you some examples how we do that and how we automated all the entire process of the operational. Now, once we have this disaggregated model and disaggregated architecture, it provides also a new economic model. And we are a software company. And usually, when their capacity grows, the cost of the network for the service providers increase with the growth because they need to buy new gears to run this extra capacity. Since we are a software company, our model is with a fixed license. So the customer, from our perspective, we just sell software. So the customer can get a fixed software license. And when he needs more capacity, he just buy more white boxes directly from the ODMs at a cost-plus model. So this is how you can reduce your cost of the network because you have the fixed software license and you just need to buy more white boxes when you need to expand. So this is how you get the benefit of the disaggregated model, of the open architecture to get the benefit for the customers. So if we need to summarize, if we think what you can get from the disaggregated model. So we have a low-cost model based on white boxes, based on open architecture, based on the fact that we can run multiple services over the same infrastructure. We have high operational efficiency because we can use the same building blocks across your network because you have the same software package running on all these locations. And we have the ability to create new revenue stream by adding more services to running the same infrastructure which was built to run more services.
Do you have any partnerships today with third parties to integrate?
So we start talking about companies. We didn't announce any integration with them, but we started to work with third parties potentials to work with the same architecture.
What's the model for that? How do third-party services plug into the fabric?
So it depends on the third party. It depends on their nature of their service. And since we didn't announce it, I don't have all the details, but this is the model, and it is built so it enables to run on the same infrastructure, third-party containers. Okay, they will run separate on different containers. They will get visibility to these resources, and they can use it for their service. And due to the fact that we already have the ability to run the same architecture across your network, it enables them to introduce this service end-to-end, because you can run their services over the same modules across the network.
So is there any type of open API or?
Yes. Modeled in open API exactly for that.
Okay, great.
Yeah. Okay, so this is for the overview. For the next session, so this is the structure of the network cloud. We have the DNOS, the distributed NOS, with hardware abstraction layer, the HAL, and the northbound interfaces. We have the DNOR, the orchestrator, and we have the white boxes that we just described. So this was the overview. The next session would be DNOS architecture. Amir will give you an overview about the DNOS. Then we will have a session about the benefits of the disaggregated model. Chen will talk about the benefits of the disaggregation and how can we see these benefits in real use cases in the field. And we have the last session would be about the DNOR orchestration. How do we orchestrate this model? How can you get those zero-touch provisioning? And how you can see, and we will also show some examples from the application to see how it works.
Okay? Before you go on to that,
Yeah.
who do you consider to be your customer? What are you aiming for? What type of customer?
The customers?
Yeah, what type of customers? Large enterprise?
Large
shop?
Tier 1 service providers. So we start with the big service providers, because if you think about the scale of these clusters, how many customers need, 100 terabits per second of a cluster. So naturally, we look for these big service providers, and then we start to go down from the core to the edge and then to the access. These
You're
are the
really trying to replace all the old stuff that they've kind of been running and
Exactly.
messing around with for years.
Yes.
So I get the need for capacity growth with the provider space. That makes a lot of sense. But what new services are you talking about specifically that you're seeing providers, other than just more bandwidth, more connections?
So we start with more bandwidth and, just to get this disaggregated model to their network. This is the first step. So they have this ability, because even without new services, they get a lot of benefits just by replacing the chassis-based model to this disaggregated architecture. The cost with the scale and the simplicity of the operation, these are the first benefit they get. The new services is the ability to, because they want to introduce new services. For example, when you think, it's more complex, I'm not sure we have the time right now to get into it, but it's, as the one in general get more, it become more important when you think, because things move from the LAN, from the enterprise to the public clouds. Now you need to get a service that they include the transport, the one from the enterprise to the transport to the one to the public clouds. So we think about other services that can combine all these together and give these services to the middle. Okay?
You're talking about I think you used the word overlays or virtualization. So you're creating some SD-WAN type of service on top of the routers, or you're not into that space?
So
No, today we're not in that space. Today we're focusing on core aggregation service routers and using the clusters to create a very flexible and big type of these routers.
Okay, so you're focusing just the WAN segment. You're not into the data centers.
not now. Okay?
Do you feel like you'll eventually get to the edge?
Yes, we feel that we started if you think about the core, the edge to the access, we started with the biggest, the more tough challenge, and we believe that once you start with this high-scale challenge, it will be easier to go down to the edge and the access. Okay. But for sure, this will be the direction.